Hi, my name is Marianne. I am a fourth-year PhD student working with John Gutag and Adrian Dalka. I am interested in computer vision for medical imaging, and specifically I care about uncertainty and generalization. My most recent project is called Taiki, and this project is basically aimed at tackling two challenges that limit the application of AI in the healthcare world, and specifically in medical imaging. So the first challenge that limits the use of AI is that for every type of image, so for example MRI, X-ray or CT, and every new anatomy, so for example brain, lungs, eye, hip bone, then you need to train a new AI. And that is very expensive, both in terms of equipment, but also in terms of expertise. And so it is not necessarily easy to adopt for clinicians and biomedical researchers. So the second challenge is that typically different experts will disagree with one another. So for example, if you take a lung CT and you're looking for a lung nodule in there, you ask 4 different experts and you're very likely to get 4 different solutions that can be very different from one another. And this is something that typical AI models don't necessarily take into account. And so one way to go around it is to actually capture this uncertainty in your model. And so basically that's the goal of my research, is to propose this one model that we call Taiki, where we propose a solution to those two challenges jointly, where it's a model that you train once that can be easily adapted to different modalities and anatomies, and that can capture uncertainty by basically proposing different candidates' solution to the problem. So the other challenge is that when you want to get your model to generalize, and you just give it an image, you need to tell it what you care about in that image. So for example, if you have an eye image, there is no way the model can know without you telling it that what you care about is just the vessels and not some other structure, like the disc, for example. The way we do that is just by giving the model examples. So the model gets as input an image, and it also gets 16 examples of what it is you care about. So for example, if we take again the eye example with the vessels, then the model needs those 16 examples of eye annotated with vessels, so different examples. Right? One last thing about Taiki that I find really cool is the way we train it, so the way we teach our AI model to output multiple predictions that are actually different from one another. And the way we do that is with laws that only backpropagate, so that means only use the information for the best predictions. So that means that if the model outputs only one prediction that's very good, and all the 3 others are very, very bad, we choose to ignore that at training. And the reason for that is that over time, and after seeing different examples from different annotators, the network will hedge its bets and output predictions that are very different from one another without always outputting the same predictions 4 times. And the intuition for that is, you can think about it, is as a coin flip, basically. So if I'm trying to predict what's the outcome of a coin flip, it's like heads or tails, right? And if I tell you, well, tell me what the outcome is, but you can only tell me one solution, then the only thing you can, the best thing you can say is 50%, right? You can say yeah, 50% heads or tail, I don't know. But if I tell you, well, you can say 2 things, then you can say it's either heads or tail. And if I look at what happens as heads, then you will not be penalized for having saying tails, because you told me accurately what happens. And maybe at some later point in time, you do the flip again and you get tails, and then you're also correct for having said tails in front of your options. So that's the way we train. I think that's pretty fun. In my field, in AI right now, I think everyone can see that things are moving extremely fast, and it's very hard to predict what things will look like even a year from now. I think right now I'm just starting a new project, I guess, still looking at this idea of uncertainty, and then I guess I will look at what is that for me next in the future, I guess a little bit later on, I guess. I'm very interested in like research. I like to think about those research questions, problem solving, and then trying to think about something that can be actually useful for people. So that's why I think medical imaging is like a good field for me right now.